Our next speaker is Pete Watt, who will use the Gisborne region as an example to present a framework to spatialise the National Exotic Forest description. Pete leads the resource monitoring team at Indufor. His primary focus at Indufor is the development of solutions that use remotely sensed data to monitor changes in forests and landscapes. Welcome, Pete.
Oh, thanks, Mike. Yeah, thanks for the introduction. So, changing gears a bit here, I'm sort of looking at today presenting something, sort of taking a spatial approach, I guess, to the National Exotic Forest description. And it's probably just worth noting this has been a bit of work that started with a collaboration between School of Forestry, so Bruce, Justin, Vega, and at School of Forestry, and also Scion, so Grant and Mike. And the intention really was to sort of start to build or put together a framework where you could sort of take satellite data and then try and use it to extract information. At that stage, it was there was no funding available, but we all realised it was sort of quite a worthy sort of application. So I've sort of pulled together what we've got here is that what Indufor has got up to. In a way, we're sort of looking to support our forestry team who are involved in forest due diligence and valuation activities. And the presentation sort of presents a sort of a pathway where we could use remote sensing to describe the plantation estate. So it's more of a strategic sort of point of view, where we attempt to build a picture of wood flow potential, say within a defined regional wood flow basket. I won't go into a heap of detail on the wood flow stuff. It's probably more of a topic for the forestry team. So just jump to the next slide. So the current NEFD, as we sort of know it, it's a pretty useful document. It sort of underpins quite a lot of policy development in regional planning and investment decisions. But it's sort of also sort of a tier 1 document, so it doesn't have a spatial type approach at all. So and it sort of also omits sort of some of the smaller plantation owners. But in the wood flow regions here are sort of shown, it's quite broad. So the statistics we're sort of getting at forest area, age, class, tending, species and ownership. So if we sort of jump to sort of a spatial point of view, we could look at how we could extract this sort of information from, I guess, satellite data, and in particular using sort of the LiDAR data and satellite information. So looking at sort of extracting plantation area, species, age class, and then going to estimating volume, say from LiDAR or yield tables, and using the satellite data to sort of update for change. And we don't really have, at the moment, anything on ownership or tending, so that's sort of work in progress. Maybe I'll just shift to Andrew, who can sort of explain some of the methodology here.
Yep, thanks for that intro, Pete. So, as Pete kind of alluded to, we started with a 1 to 50k topo tile in the Gisborne region. And it kind of made sense to use this kind of area because it was covered by the East Coast regional LiDAR. So that's a really, really rich data source and has a lot of applications beyond forestry, but it's very useful within the forestry realm. It also made sense to use it alongside Sentinel-2 optical data, which we've had quite a lot of experience with for landscape scale classification. I'm sure most of you are aware that Sentinel-2 is an open access sensor, captures images every 5 days. But as Dave alluded to before, this is to land in a long white cloud, and yeah, there's no guarantee of cloud-free captures every 5 days. It has a resolution of 10 meters. We've done quite a lot of work in the Sentinel-2 classification realm, so it was kind of a case of spinning up a lot of the previous processes that we'd worked out for this context of creating a spatial NEFD. The one difference was with using the regional LiDAR captures is that the LiDAR is a finer resolution of 1 meter relative to the 10 meter GSD of the Sentinel-2 data. So given that resolution difference, we looked to basically create a harmonized 10 meter resolution data set that captured the average canopy height, but also some texture metrics of the of the LiDAR to really give us a bit more of a boost in terms of our classification accuracy. So those resulting, the resulting combined Sentinel-2 optical and the LiDAR images were classified just using a random forest approach. But we also introduced an object-based clustering step into the process just to try and reduce some of that, that noise that you get and look at things on sort of a spatial patch level as opposed to per pixel. That also makes it a lot easier subsequently to generate vectors and polygons describing these forestry units, which is also obviously a lot more useful for this sort of approach. Cool, so just some quick results. And you just see here, we've got the Sentinel-2 seen on the right, and then a canopy height representation of LiDAR data. This is what the classification looks like. So you see we've got a number of classes: native, harvest, exotic plantation, new planting, and also bare land. This is what it looks like when we extract the exotic forest class and turn that into a vector. So you see that gives us quite a nice boundary delineation in a fully automated way from those input data sets. So just some numbers, within that 1 to 50K topo tile, we mapped just under 300,000 hectares of exotic forest, just with an NMU of 0.1 hectares. That was across about 15,000 different patches. The largest contiguous area of exotic plantation was about 7,000 hectares, with a slightly lower total area classified as native. We also picked up about 2,500 hectares of harvesting. So there were a few challenges that we noted. There was some confusion between planting and harvest. There were some struggles to define the exotic plantation in areas with like really low stocking. And it was also quite tricky to define areas of native, which were quite narrow and also followed topography. We will go into the age prediction a wee bit more in a later slide, but we do note that with the introduction of more carbon regimes, deriving a pure like height age relationship is a bit more tricky when you have forests that reach mature height and stay there without harvesting. So just digging into the age class stuff a wee bit more. So for all those patches that were classified as exotic forest, we generated just a simple regression model that combined the LiDAR-derived canopy height and elevation along with latitude and site index inputs. So this is kind of following a discussion with Scion. We had access to about 255 stands of known age across the East Coast region. And we used that to kind of train this simple regression model. And we kept kind of a 30% holdback just for validation. And you can see that in the plot to the right here, what the results were in terms of comparison between what this ground truth age was and what the model was predicting for that stand. So you can see that the results are generally pretty good, and kind of 70%, sorry, 86% of the results were within a couple of years of what the established ground truth value was. We will say that this is definitely a work in progress, and given that this is a relatively small region compared to the kind of national area, there's certainly a bit more development to go in this process. Cool, so just a few, just a quick discussion on what the outputs look like. We decided the best way to actually get across these results was to wrap everything up in a simple web app. You can see that just in this animation here. Basically, it's just an interactive interface where you can go through, look at the different base layers and relative to the planted boundaries, but then also have a look at some of these other derived layers, such as the predicted age, predicted volume, mean top height. And you can also actually click anywhere and query what the actual results are at any given point. So that can be quite useful to just understand a bit more for a given area that might be more relevant to you, rather than just presenting everything at a really sort of macro level. The other neat thing that we can do once we have these exotic plantation boundaries defined is to actually use the subsequent Sentinel-2 captures to update the planted area by detecting harvest. So you can see that here that we've got a couple of captures post the initial classification date. And you can see there's clearly evidence of harvesting there. And just applying a similar process, we can knock out these areas that were originally within the planted area bounds and list that as harvesting. So basically, we're using LiDAR and satellite to define our planted area, a combination of the LiDAR texture metrics and the spectral characteristics of the pixels to define class. We're looking at age, volume, and mean top height from the LiDAR. And then we're kind of looking to update those initial baseline results using subsequent captures of the Sentinel-2 data. And this basically builds towards the data set that will be fed into a forest estate model. Cool, so I'll just hand it back to Pete.
Okay. Well, thanks, Andrew. So if you want to check out that demo, that link there will take you there. So feel free to jump in and have a look at that and have a play. Probably makes more sense on your own desktop than us perhaps showing you the app there. So really just, there's only a couple of more slides, but just to sort of bringing this together, and these are my ideas, so feel free to disagree with them. But really thinking at a high level perspective, what the value would be if you actually had a spatial approach to the NEFD. So potentially it gives you further insights into how you could bring in the small woodlots which are perhaps not captured so well at the moment. There's a bit of uncertainty around that. And also it allows you then to sort of build, I guess, wood flow analytics across any area like, so you're not stuck with, for example, the wood flow regions. You can do it for a designated wood basket. So the other ideas here are listed sort of like investment side. So it's really just building forest descriptions and getting it in a spatial format. So sort of support underlying policy or wood processing strategy, or even from a different angle, looking at environmental compliance. So you don't need, the nice thing about this is you don't need to go and use someone's GIS to build the forest area. You've already got that. So you're not asking people for their GIS layers. And once you've got the forest mask, all you're doing is basically building the information from that, and then you can populate it into a number of different formats. Sorry, I actually forgot about further improvements. So we're looking here also bringing in some of the ideas around AI or deep learning, and it's probably more in the wheelhouse of Scion at the moment, but using sort of those technologies to improve the delineation of the boundaries and also do some classification with it. So with an idea to improve that baseline. Also looking then at bringing in a little bit more field data to, I guess, add a bit more rigor to the estimations, and also potentially stratify by productivity across forests. And the last point would be looking at refining the tending and the regime information. So we haven't really had a good opportunity to do that yet. So while we show you that quick overview, I guess actually we've been quite busy within this area, sort of looking at other potential sites and also other work as well. So there's some quite good examples on the webpage if you're keen to have a look, which the one on the left is using sort of a dashboard approach to monitor harvesting and harvesting progress. So that's active. And the other one is actually an example from the Australian version of the NEFD, which is MPI. So for the Green Triangle region, just basically refreshing that. So for the Australian example, they have a spatial outline, but they don't generally have it really detailed. So updating the boundaries using satellite data and then populating it with relevant information like age class, species, and area. That's quite helpful. And I'll probably just leave it there, actually, Mike, and hand back to you.
Yeah, thanks for that, Pete. That was really good.